Alright, so here's the oxygen for the ozone. When you put them together, a couple of things you have to keep in mind is we need to use the right number of electrons. So this was 6 and 6 and 6 for a total of 18. But you also have to satisfy the octet rule. So this one's actually pretty tricky. One way to do it is if you have the oxygen on the left, keep all of its 6 electrons, 2, 4, 6. The oxygen in the middle donates 2, so shares 2. So that's where you get a single bond here. And then the oxygen on the right keeps 2, 4 of its and shares a pair with the oxygen in the middle. And the oxygen in the middle keeps 2 of its and shares a pair with the oxygen on the right. So then you actually have a double bond. So you end up with single bond, middle, double bond, and then you have what are called lone pairs that are on just one atom, aren't shared pairs. So you end up with a single and a double bond. And this is the only way to do it where all the atoms have an octet, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And you have the right number of total electrons, 18 electrons, 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's the two things we always have to do, is we always have to have the right number of electrons, so 18 electrons, and we have to satisfy the octet for each atom. So rather than have to brainstorm every time, we have a system of rules that you can follow. So we'll do 3 examples. I'll do the first one for you and then just have you try the next 2. So example 1, here this is ammonia, NH3, and I'm just telling you that nitrogen is in the center. So draw simple electron dot symbols for each individual atom. So I need to look at my periodic table. Nitrogen is here, helium, and then 2s12, 2p123 for a total of 1, 2, 3, 4, 5 dots. So nitrogen with 5 dots, 1, 2, 3, 4, 5. Doesn't really matter what side you put them on. I just prefer to put it that way. And then hydrogen. Well, hydrogen just has 1 electron clearly, so just 1 dot. So I'll have 1 hydrogen. I'll put it here. Another hydrogen. I'll put it over here. Another hydrogen. I'll put it down here. Oh, you can see how this is going to kind of work, where we're going to make 3 bonds. All right, but that's determine the total number of electrons. So again, the nitrogen had 5 electrons. 1, 2, 3, 4, 5. And each hydrogen had 1. So 3 times 1 electron equals 3. 5 plus 3 is 8 total electrons. That's it for step 2. Because we don't have a positively charged ion or a negatively charged ion, this is neutral. And we know that because there's just nothing there, so no charge. All right, choose the central atom. I told you nitrogen's in the center. Connect the outer atoms to the central. So we'll just connect with single bonds. Now remember, each single bond is the same thing as a pair of electrons, so I could have also drawn it like this. Okay, then complete the octet rule for each atom by adding 3 more pair of electrons to make a total of 8, except if it's hydrogen. Hydrogen only gets 1 electron pair, period, and they already have it with the bonds. So I don't have to do anything here. So my status is still this after this 4th step. And then the 5th step, count the number of electrons you have currently drawn. So remember, each line is 2, so 2, 4, 6. If it's less than the number calculated before, add electrons as non-bonding pairs around the central atom until these numbers are equal. So this is 6, which is less than 8. So I need to add 2 more. So again, this is 6. And then if I add 2 more, then that will be 8. And now it's equal. If the number of electron pairs around the central atom is greater than or equal to 4 pairs, 2, 4, 6, 8. So it is equal to, you are finished. So I'm done. So that's my final answer. So this one's complete. I have 2, 4, 6, 8 total electrons, which is what I needed. And the octet is full on the nitrogen, 2, 4, 6, 8. So this one's pretty easy. If it's less than 4 pairs, which it's not, draw multiple bonds by borrowing electron pairs from the outer atoms until the central atom has 4 electron pairs. So we'll look at double bonds in the next example. So I'm kind of giving you a hint. Try example 2 with carbon dioxide. And I'll write that out and then talk you through it. And then for example 3, try this ion, H3CO-. And remember, that'll be different once you get to here, negatively charged ion, add 1 electron, because electrons are negative. So again, in the next video I'll show you the answer, but carbon dioxide, try that for example 2. And then for example 3, H3CO-. All right.